I'm Quinn McHenry, Senior Developer at Small Planet Digital, and I'd like to introduce you to GenKit, a new framework and tool that we've been using internally in our apps that helps make coding better and easier. Why did we make GenKit? Ultimately, two things factor into it: being safe and lazy. Lazy is one of my primary goals as a developer, but it's pretty rare that we get to be both lazy and safe when we do it. By safe, I mean we can define data in YAML files, and a file that's easily maintained by humans provides a single source of information of constants or things that the apps need to use that provides parity between platforms, for instance, or even just a convenience. It allows non-developers to get in and change things that can affect the code without actually touching the code. And from a lazy perspective, we can use simple templates to transform the data stored in that YAML file into whatever we want, any kind of text we want. It makes repetitive code generation automated and easy, and it can generate things that aren't code, like wiki documentation or cookbook if you're really going crazy. And finally, we get to achieve the ultimate goal in life of replacing someone with a tiny shell script. The data is stored in YAML format, as I mentioned, which is something that's a lot like JSON, but has a beautiful format. It's easy to read, and normal human beings can understand it and edit it. It is versioned really nicely and can be edited straight in GitHub. The top-level data in the file should be a dictionary, but then anything goes after that. Anything that's legal in a dictionary can go in there. Here's a simple sample. One of the things I like to use it for in our apps is maintaining the list of keys, event names, and parameter names in analytics, which is really great in a cross-platform app to keep those two things in sync. Here we're defining a simple set of event names like application foregrounded and some of the properties that we'd send along with it. We'll see in a few slides what that looks like when it's generated into some different code languages. YAML is like JSON. Functionally, they can be converted together really easily, but it's a little easier to write and read, and you can actually put comments in it, which is great. GenKit adds a meta dictionary of extra stuff. If the key GenKit doesn't exist, it'll add things like date, time that the code is run, and what template was used. These can be great for header documentation and such. All comes down to the template that we use, and we've played with two different kinds in our application development, and both of these work great. So we started with Stencil. Later we found Mustache. They're both really great things. They have different capabilities, but they're roughly equivalent. So whichever one you like, you can use very easily with a simple command line switch. Using GenKit is straightforward. This GenKit is essentially a love letter to Swift Package Manager, which is ultimately GenKit is a very simple bit of code that glues together a lot of other libraries made by other people and shared. And ultimately, using Swift Package Manager is really easy. We just type Swift build within the directory, and it creates it. One of the nice things it does, though, is it creates both a tool called Gen and a framework that Gen depends on called GenKit. We can talk about those later. For full usage instructions, we can check the README at GitHub. One thing, if you're generating code, checking to see if the generation is necessary is a great thing. It prevents unnecessary work, prevents the compiler from possibly rebuilding your entire project, even though nothing really changed. So GenKit allows you automatically, if it knows what the output file is, it can check to see if the input has changed since the last time the output was created, if the templates have been edited, and you can add additional command line options to check for other files that may be dependent. So within GenKit are a couple of samples, both inputs files and different templates. The analytics keys file that we saw earlier, there's a longer version of that in the project. And if we run that through this Swift template written in stencil, which looks a little bracy and stuff, but ultimately it comes down to being pretty simple. It has for loops within it, possibly a conditional, lets us create something that looks like this automatically. So creates a structured hierarchy of analytics keys, and that are ultimately easily accessed, in this case with something like analytics keys.application.event name. It's safe because at compiler time we know this exists. We're not using a string literal that could be accidentally copy and pasted wrong or mistyped. But this same input file can be run through a stencil template to generate C++ headers and source code. And it looks similar but different, obviously, because of C++. And the same thing can run through and create a Java file. Having these things be in sync between different platforms in a project just lets a lead developer sleep better at night. So integrating GenKit requires great detailed mathematical knowledge. Not really, it's actually very simple. In the case of Xcode integration, it just requires a simple build phase script that runs automatically while your target's built. It does a Swift build to generate the framework and tool, and then uses the Gen tool to do whatever you need to do. Here's a sample that generates a things.swift file from a things.yaml file using a Swift mustache template. Copied and pasted and slightly modified for your project. This would work as a Swift and Xcode build phase. Good to go. Customizing GenKit. So the nice thing about using Swift Package Manager is that you can make multiple targets within a single package. If you look into package.swift, you'll see that there are two defined here, Gen and GenKit. Gen uses GenKit as a package. And in a similar way, other projects can easily import GenKit as a dependency, and you build upon that to make tools that maybe don't need to use a simple YAML file. An example of that is this Lion project, which is also hosted at GitHub, that reads in localizable strings files, which are definitely not YAML, and generates a type-safe hierarchical set of structures that can be used in code really easily and safely. Along those lines, if there are cases where more processing needs to be done than can be done just to a simple YAML file, or that you don't want to do outside of the tool, it's really easy to create a new package from the command line with Swift Package Manager and just get going up to speed really quickly with GenKit. GenKit's built with, as I mentioned, a number of open source packages. Command line makes building command line utilities really easy. YAML, obviously the engine of this, be easy to drop in a JSON parser or use Swift4's new JSON encoding, decoding capabilities to enhance this further. Mustache, we're using the IBM fork of GR Mustache, as it's a little more actively developed, and they're doing great work with that. And FileKit just lets us adds a little syntactic sugar for file access and management. And that's it. I hope you find GenKit useful in your projects, and go forth and be lazy.